Wave is the most important forcings which acts in the coastal environment. It is defined as oscillations that travel and transfer energy as shown in this animation. Here we observe that the individuals involved in this human wave form undergoes only a repetitive action. However, as a result of that, we actually can see a wave being created, and the wave actually travel or propagates from one end to another end. Specifically for coastal wave or ocean wave, they are generated at the interface between two fluid, one which is the water itself and the other one is the air, and it is this wave that forms at the interface that travel and transfer the energy from typically the offshore region to the coastal region. If we examine wave more specifically, then we may define wave as a simple wave such as a sinusoidal wave that we see here with a repetitive regular motion, or we may have complex wave which looks like this. Now a wave is said to be periodic where its oscillations repeat periodically, but we may also have waves which are defined as solitary, which means that there is only a single wave that moves relative to the fluid mass. Example of these would be tsunami or backwater. Propagating wave. And whereas here on this slide we see an example of a solitary wave. We have earlier looked at the animation of a progressive wave or propagating wave, whereby we can clearly see that the wave energy propagates forward with respect to a fixed point. Now in a propagating wave, the particles similar to the animation of the human wave that we see earlier, they don't move, they are just repeating the motion at the same point. But there will be cases whereby we might observe translatory wave, which means that not only the wave is propagating forward, but then the individual particle are also slowly moving forward. That means there is a net advance of water particle in the successive wave. If we try to imagine it, that means the human chain that create the human wave just now, not only they are just moving up and down in their fixed position, they are also slowly moving in the same direction as the wave. Then it is called a translatory wave. Meanwhile, we may also have standing wave. Standing wave is a phenomenon whereby a wave moves up and down at a fixed point. This is an example of a standing wave. Usually a standing wave happens when a propagating wave is reflected by a fixed boundary, so that the incoming wave and the reflected wave collides into one another and forms a standing wave or phenomena like this. Now in a wave motion, like again the human wave that we see earlier, they are made up of individual particles participating in the wave motion. So right now what we want to examine is the wave particle motion. In a human wave, the individuals move up and down. All right. So in wave, actually we have different types of particle motion. We have transverse wave, whereby the oscillation occur perpendicular to the direction of the wave, such as a wave on a piece of string. We may have longitudinal waves whereby oscillation occur parallel to the direction of the wave. Example of these would be sound. And more specifically for water wave, we are able to observe orbitary motion, whereby the oscillation occur in a circular motion with zero mass transport. Again, if there is a mass transport, then that is a translatory wave. Here's an example of a transverse wave. We can see that the wave propagates in the left-right direction, but the particle motion is in the lateral direction, which is perpendicular. This is longitudinal wave. Again, we can see that the wave propagates in the left-right direction. At the same time, if you look at individual particles, right, if you pick any particles on this slide, then you notice that the particle is also oscillating in the same direction as the wave. This is an example of sound waves. In this case, this may be the diaphragm that generates the sound, and so this is the wave generated and propagates outwards. But of course, in this lecture, what we are interested in is water waves. This is the orbitary motion of water waves. You can see the surface wave profile over here. Actually, inside here we will have particles that move around in orbital motion. The orbital motion is the largest near the surface, and it reduces as we go deeper into the water. And at some point, the orbital motion of the particle will diminish. That means there's no orbital motion, which means that for a deep water, wave can only be felt near the surface, and it cannot be felt at a much deeper depth. All right. And because of this orbital motion, if we imagine a blade of seagrass here, then we can expect that the seagrass motion is smaller at the lower end, but the seagrass motion will be larger at the higher end. This is an example of the orbital motion, where we can see, again, over here we have a wave that is propagating from left to right. You can see that this blue particle right at the surface has a relatively larger orbital motion compared to this blue particle, which is also in orbital motion but with a smaller radius. And as we go further into the water, then we notice that the particles further down has much less orbital motion. So we mentioned that as long as the orbital motions of these particles maintain at the fixed equilibrium position, then that means no particle move forward. So this is a purely progressive wave. If there is a net motion of the particle forward, then that is called a translatory wave.